We are again continuing the Newton's laws of motion, and the topic now in the Newton's laws of motion will be the circular motion. Regarding circular motion, one of the very important facts is that when the particle is moving in uniform circular motion, the speed of the body remains constant, but velocity at the different instants of time will be different. Velocity is indicated by drawing a tangent at a point on the circular path. So whenever particle moves from one position to another position, the direction of tangent changes. Hence, the direction of velocity also changes, but speed remains constant. So whenever particle is moving in circular motion, the fact to remember is that speed is constant, but velocity will be variable. And momentum of that particle will be in the direction of velocity. So linear velocity will be depicted by m multiplied by v, and that will be in the direction of velocity. So in the circular motion, centripetal acceleration is directed towards the center. Whenever particle is moving in circular motion, the tension in the string, which is directed towards the center, provides the centrifugal force, which is opposite to centripetal force. So centripetal force is basically a centrally directed force. However, centrifugal force is not a reaction to the centripetal force, but it is provided by the tension in the string. However, the magnitude of centripetal and centrifugal forces are equal, but their directions are opposite. So in the circular motion, we will brief it: speed constant, velocity variable, direction of momentum is the same as that of velocity, and tension in the string will provide the centrifugal force. Centripetal force is a centrally directed force. Magnitude of centripetal force and centrifugal forces are equal, and directions will be opposite. And acceleration towards the center, that will be known as centripetal acceleration. Now we come to the main context of the circular motion. First is the centripetal force. So in circular motion, the force acting on the particle along the radius and towards the center keeps the body moving along the circular path. This force is called centripetal force. That is, centripetal force is centrally directed force. Centripetal force is necessary for the curvilinear motion. Curvilinear means the particle is moving in uniform circular motion. It is along the radius and towards the center. So centripetal force operates towards the center and along the radius. Now, in order to find the centripetal force, we can use the linear velocity as well as the angular velocity. The centripetal force will be the product of mass and centripetal acceleration. So, centripetal force is equal to mass into centripetal acceleration. Mass will be m and centripetal acceleration will be v square over r. This we can write in the form mr omega square. Normally the point to remember is that omega is equal to v over r, or omega square will be v square over r square. So if you will make the necessary calculations in mr omega square, the value comes to be mv square over r. Now the fourth point is centripetal force is due to the known interaction, that is the interaction between the center and the particle moving in circle. Therefore, it is a real force. If an object tied to string is revolved uniformly in horizontal circle, the centripetal force is due to the tension imparted to the string by the hand. So tension is responsible for providing the centripetal force. Now we can have some examples, like when satellite is revolving in a circular orbit around the earth. The centripetal force is due to the gravitational force of attraction between the satellite and the Earth. For example, if Earth is moving around the Sun, like we know that Earth is moving around the Sun, so there will be gravitational attraction between Sun and Earth. This gravitational attraction provides the necessary centripetal force to Earth, and Earth starts revolving around the Sun, and the centripetal force will be directed towards the center. And now we'll take the case of electron. That is, if electron is moving around the nucleus in an orbit, then electrical force of attraction between the nucleus and electron will provide centripetal force to the revolving electron. So the nature of force is electrical. It is directed towards the center because center is more dense as compared to electron, and centrally directed force is also known as centripetal force. It means that electrical force has a magnitude which is the same as that of centripetal force, but the outward force will be centrifugal force. So, if electron is revolving around the nucleus and electron is not falling into the nucleus, that means that the magnitude of centripetal force and centrifugal forces are equal, but the directions are opposite. Now we can explain it in this way. In an atom, an electron revolves in a circular orbit around the nucleus. The centripetal force is due to the electrostatic force of attraction between the positively charged nucleus and electron. Force F is mv square over r, which is not equal to 0. So the body is not in equilibrium, and linear momentum of the particle moving on the circle is not conserved. So linear momentum will never be conserved because there is angular velocity. So angular momentum in this case will be conserved. So however, as force is central, that is tau is equal to 0. So angular momentum is conserved, that is P is not equal to 0, or P is not constant, but L is constant. The work done by centripetal force is always 0, and it is perpendicular to the velocity and hence the displacement. When we say the work done, it means that particle is moving in circle. So net displacement will be 0, and that's why the work done is 0. Now, the another concept is by work energy theorem. When we use the term work energy theorem, we are referring to half mv square minus half mu square, where v and u are final and initial velocities. So by work energy theorem, as work done is equal to change in kinetic energy, delta K will be 0, where K is kinetic energy remaining constant. Now we come towards certain examples in which we are using the centripetal forces and centrifugal forces. Now in one of the example, our assumption is like stone of mass 1 kg is whirled in a circular path. Radius of the path is 1 meter. We have to find the tension in the string if the linear velocity is 10 meters per second. So whenever the stone will move in a circle, the tension in the string will provide the centripetal force to the stone, and stone will start moving in circular motion. So we can say tension is equivalent to mv square over r. So now in the solution, the very first thing is tension is mv square over r, where r is the radius of the path, m is the mass, and v is the velocity. All the parameters are being given, so we can put the values of mv and r, and the tension is calculated out to be 100 newtons. We can also represent this value in terms of dyne. If 100 newtons is multiplied by 10 to the power 5, then the whole number will become in dynes. You can remember that Newton is a MKS unit of force and dyne is a CDS unit of force. Now we come towards another example. A satellite of mass 10 to the power 7 kilograms is revolving around the Earth with a time period of 30 days at a height of 1600 kilometers, find out the force of attraction on the satellite by the Earth. So, which is the more important thing is that mass of the satellite is being provided to us and it is moving around the Earth. So, whenever satellite is moving around the Earth, there will be attraction between the satellite and the Earth. This attractive force or this gravitational attraction will provide necessary centripetal force to satellite, due to which the satellite will go on moving around the Earth. So satellite moves around the Earth, the reason being the attraction between the satellite and Earth provides necessary centripetal force. Another part of the question is that time period is 30 days. So we can multiply 30 days with 24 because each day of 24 hours, so 30 multiplied by 24 will provide the number of hours. But we have to express time in seconds. So whatever number we get in hours, we multiply that number by 3600 and that will become seconds. Now the object or the satellite is moving at a height of 1600 kilometers above the surface of Earth. So we must know what is the radius of Earth. The radius of Earth is generally taken as 6400 kilometers. So 1600 will be added to 6400 and then after adding the number is reduced to meters by multiplying by 1000. This is what indicated in the solution. We have to find the force of attraction on the satellite. Now, in the actual calculation, the force is calculated by mass into acceleration, and acceleration will be omega square r. And we know that omega is 2 pi over time. Now we compute the values, that is 2 multiplied by pi. Pi is 3.14 and time is 30 into 86,400 and the number will be converted to seconds. So after calculating this value, we again write force m omega square r. Now what we do, we put the value of m omega square as we have calculated earlier, and then for r we will compute 6400 plus 1600 multiplied by 3. So the force calculated will be 2.34 10 to the power 6 newtons. Now we come towards what is tangential force. In circular motion, the force acting on the particle along the tangent and keep the speed of particle changing, and that is what known as the tangential force. So tangential force is given by function Ft is equal to mat, where Ft is the tangential force and At is the tangential acceleration. The direction of acceleration is always towards the force. Now we can see the diagram. In the diagram, F is indicating the centripetal force, or F is indicating that is the force, and centripetal force is inclined at angle theta to F. Fc is the centripetal force, Ft is the tangential force. So it is forming a right angle triangle. Wherever it comes to be a right angle triangle, we can use Pythagoras theorem. So tangential force is basically in the circular motion, the force acting on the particle along the tangent. Now what is the net force on the particle? That is what we have to calculate. So now net force is calculated by using the Pythagoras theorem. So there will be a triangle formed in the figure, and if it is a right angle triangle, the hypotenuse, that is hypotenuse square will be equal to sum of the squares of the two sides. So net force on the particle is F, and that will be Fc plus Ft. Now we can take this number as F is equal to Fc square plus Ft square under root. If theta is the angle made by F with Fc, then tangent theta will be the ratio of perpendicular and base. So Ft is divided by Fc, and that is equal to theta, and theta is tangent inverse Ft over Fc. Now the important note is that angle between Fc and Ft as we are seeing in the figure, that is 90 degrees. Angle between F and FT will be 90 minus theta. So we can use the allied angles in the calculations. Sin 90 minus theta will be cos theta, and cos 90 minus theta will be sin theta.